A galvanometer is a device that measures the amount of current passing through it by exploiting the relationship between that current and an applied magnetic field. There are two ways of thinking about this relationship. One way is to think about the current in the coil as generating a magnetic field and acting as an electromagnet. This electromagnet will have a north and south pole, and these will be attracted to or repelled by the north and south poles of an external magnet. The electromagnet will try to twist to orient itself with the other magnet, but we have a coiled spring to resist that twist. The more current, the more it is able to twist, and the more the needle moves. Another way of thinking about it is that the moving charge carriers in the wire, the electrons, feel a force as they pass through the magnetic field generated by the external magnet. The effect is the same. You'll notice that for the ammeter shown, we are placing a galvanometer in parallel with a resistor. This resistor is known as a shunt resistor. It has very low electrical resistance. This means that if you attach the system to a high current, most of the current will pass through and dissipate in the shunt resistor and not in the galvanometer, where it might melt the wires. The scale of the galvanometer is shown at the top. The scale is calibrated based on the strength of the coiled spring. A stiffer spring would not let the needle move as far for a given current. If we increase the strength of the external magnet, the needle will move farther for a given current. This means we need to recalibrate the scale at the top of the meter. Likewise, if we add more loops to the system, we create a stronger electromagnet, and the system needs to be recalibrated again. If we feed more current into the system, then the needle should move more. Otherwise, why are we even bothering? A galvanometer can also measure voltage. In this case, we place it in series with a resistor, known as the series resistor. We want a voltmeter to draw very little current so that, when placed in a circuit, it doesn't disturb or bypass other circuit elements. For this reason, the series resistor has high electrical resistance. Again, if we adjust the magnet strength or number of loops wrapped in our electromagnet, we'll need to recalibrate the system. We hope this is helpful to you.